All right, everyone, I guess we'll get started. 5 o'clock, and I'm the only thing between you and food. So today I'm going to be talking to you about push notifications, and specifically with PushSharp, which is an open source library that I've created. I'll talk about in greater detail in a minute. I'm Jonathan Dick. I'm a DBA developer by day and a Xamarin enthusiast all the rest of the time. And I'm from Canada. I've recently helped co-author a book on mono for Android programming with a few people who you've probably already met here. So here's just a quick overview of what I'll go through with you today, just a little bit about what push notifications are and why and how we should use them. Then I'm going to do a demo with PushSharp, and then I'm going to try and do a demo to go all the way from setting up your iOS app to sending it a notification as quickly as possible and as painless as possible with PushSharp. So first of all, these are push notifications. Wanted to illustrate all the different platforms to you and show you how they're all kind of similar, but still a little bit different. So on iOS, you've got the banner alert. On Windows Phone, it's actually a call to toast notification, and then I've mocked up something similar on the Android notification bar. So just keep that in mind. Push notifications are all fairly similar, but a little bit different on all the platforms. So it sounds kind of obvious to say that push notifications are kind of the opposite of polling. Back in the day, or maybe on desktop apps, we might have done something like go and check every 15 minutes to see if something's changed. Well, push notifications give us that update without us having to go out and get it, if there might not even be anything there for us to get. BlackBerry really made this popular with their push email back in the day. BlackBerry, not so popular now. And IMAP idle is kind of an interesting comparison to push notifications because it's kind of the same thing. So IMAP, the idle extension lets the client sit on a dormant connection, and the server sends an update whenever something happens over that same connection. And that's basically how most of the platforms from the client side of things listen and talk to the server for push notifications today. So everybody's doing it. Every mobile platform to date that I know of that's in production and heavily used actually does some kind of push notification. They have some kind of API that they're using, but everyone's got something. And I like to think that Apple invented it again because they kind of reinvented things and like to claim it as their own. Now, why should we use them? Well, it's, again, kind of obvious, but they're timely. If we're polling every 15 minutes and something happens right after the last time we poll, we're not going to know about it until almost 15 minutes later. They're very efficient. So I did a quick calculation, and I kind of figured, let's say we had an app that was going to get hockey game scores, and it checked every 15 minutes to see if something happened. Now let's be generous and say that it consumed 25 kilobytes of data every 15 minutes. If you had that app running 24 hours a day, after a month, you've accumulated almost 75 megs of data. And I know data is becoming more ubiquitous and cheaper and everything, but that's still a lot of data, and it costs people a lot on their plans if they don't have a huge plan. So they're definitely more efficient that way, and because we're not polling every 15 minutes or however often we're polling, we're not incurring those CPU cycles. Now with efficiency comes scale, obviously, kind of natural, but the way that Apple sort of decided to go and not let you run apps in the background has really increased the scalability for delivering updates to apps. It means that every app isn't running its own process. Like on Android, we could, because we can do background services, we could actually do our own HTTP LAN polling or use SignalR or something in the background, but that might be fine for one app. But if every app started doing that, well, that really bogs down quick. So on most of the platforms, the idea of push notifications is that there's one process, there's one connection that the operating system maintains, and it proxies out notifications to each of the appropriate applications. And the other big thing that I think a lot of people are more aware of today is user experience. So think of the Windows days, like the Windows XP days, when you might have an application that did balloon tooltips when something happened. You might have one that flashed your taskbar annoyingly, repeatedly. And you might have one that tried to mimic like a growl-style toast. Well, that's really not a great experience for our users, and I don't think most users understand necessarily when apps do different things like that. So the mobile platforms have a more consistent user experience, and it might be different from platform to platform, but at least as a Windows user, I know what to expect if I'm a Windows Phone user. If I get a live tile update, I kind of know what that means. Or on iOS, if I see a badge, I know what that means. So it's really a good thing for our user experience, but also as developers. So on iOS, we have the notification center, and we don't have to do any additional development for users to be able to do things like, say if they want to receive a banner or an alert box instead. That's all free to us. And things like a notification center where you have the quiet times. So the user can say, I don't want to receive notifications from this time to this time. That's all done for us. They don't have to find the settings buried in our app that might be somewhere else in another app or might not even exist. So I think that's pretty convincing why we should use them. And all of the platforms implement them in roughly the same way. Basically, you've got your device application that says, hey, I want to receive push notifications. And it talks to the cloud provider push notification gateway. And that cloud, it's going to be like Apple or Microsoft or Google hosting the servers. That's going to send back a unique identifier. And it's up to you as a developer to do something with that, whether you have your own REST API somewhere that you can post it to, or whether you're using something like Parse or Azure Mobile Services. And often you'll send along some account information with it. Maybe if the user's logged into Facebook, you'll send their Facebook account so that when something happens that relates to that Facebook user, you can send a notification to all the different devices that user might have, because they might have more than one. And that unique ID, every platform calls it something different. On Apple, it's device token. On Google, it's registration ID. On Windows and Windows Phone, it's a channel URI. But you can think of it like an address. It's like an email address or a mailing address. It pertains to that specific application for that specific user for that specific device. So those are the three things. So then when your cloud service decides that it needs to send something to that address, it goes and talks to the gateway provider, and they will ensure that that message gets delivered to the device. So the platforms, the popular ones that are doing things, just to give a quick run through, there's C2DM, which is kind of Google's now deprecated platform. And the main reason I want to put that up there is because you'll often see in the client side of things still references to C2DM. And that's okay. You're still using GCM if you went that route. The client has relatively unchanged, but the server side's a bit differently with their new Google Cloud messaging. Windows has two services because naturally we wouldn't want to do the same thing for both Windows team and the Windows Phone team. So they've got two services that are very similar but just slightly different. They do live tiles and a bunch of different notification types. And Apple's APNS server, and they do iOS, and not everyone is aware yet that it also works on Mountain Lion. So how do you send notifications? Well, I mentioned Azure already. That's a great service to use. They now support, well, you already saw it probably in an earlier talk, but they support a whole bunch of platforms. The one weird thing about Azure, if you're not familiar with it, is you kind of have to manipulate an Azure Mobile Services data table call and inject your JavaScript to actually send the notification. So it's like you might say, I'll insert a record into this table, and then in the insert script, you would actually be calling the JavaScript to send a notification. So once you know that, it's actually a really, really great service to work with. It works well. I've used it myself a lot. There's Urban Airship, who kind of sprung up from the pain of working with Apple. I should mention that all of the providers, all of the platforms, except for Apple, tend to use HTTP-based APIs, so they're pretty easy to talk to. But Apple's the weird child, and they made things just terribly difficult. And if you want to see some rants about how I feel about that, you could check out my blog. There's Urban Airship, I was saying, and I think their idea was, let's give people a REST API, and we'll do the dirty work of talking to Apple. Now they have different value-add services on top of that these days. Parse.com, pretty similar to Azure, but also great for sending notifications and doing different things. Now, So like if you're using these services for other things, I wouldn't want to discourage using them for notifications because they do work great for that. But one of my issues is if I'm doing an application, something in the cloud has to generate that event to say, hey, there should be a notification. And I don't really want to deal with a middleman in that case. So, why not talk to the gateway providers ourselves directly? And that's exactly what I had done when I started working with push notifications. I actually had 2 projects before PushSharp. One was for APNS and one was for C2DM. And then I got the idea that, hey, notifications are all really similar, but just slightly different. And there's a lot of gains we can achieve by abstracting a little bit of that similarity. So I created this library. It's intended to be a server-side library for sending notifications. And it's open source. It's on Apache 2. GitHub, go ahead, grab it, fork it, do whatever you want with it. There's a lot of forks already of it, and I'm not sure if that's a good thing or a bad thing, but people are using it, so I'm happy. There's also a client library for Android. I've basically ported the GCM Sharp Java library. And then there's also some samples to show you how to implement that. Basically, for Android is the one that's the most difficult to register for notifications. So if you go check out the sample, you basically use my ported client library and then copy and paste a 1CS file and fill in the stubs with what you actually want to do when you register or receive a message, et cetera. So that, I'm hoping to ease pain there a little bit. As I mentioned earlier, it's for iOS, and that means Mountain Lion 2, Android, Windows, Windows Phone 8, 7, and soon Firefox OS will be supported. They're still kind of finalizing their APIs. And I've actually learned from someone who's using Amazon device messaging and PushSharp, and I can't name them, but it's in private beta right now, and they've actually got the code ready to contribute back into PushSharp whenever that goes public. So we'll have support for that too, which is awesome. I love seeing pull requests from people. It's all managed code, and I like to think of the notification API to build notifications as Fluent, but I have no idea if that's proper Fluent.
Is there anything special in that for medium trust?
For medium trust? No. No, well, yes, the problem is using the SSL certificates for Apple. And in certain environments that are medium trust, you just can't do it. It doesn't allow it. So that's an unfortunate issue that you have to deal with. I have worked out, though, I worked a little bit with the Azure team on some issues on getting it working in the web role, or like an Azure website in the free sandbox environments. And I'm told that that's been rolled out, and you can do that now. So PushSharp 2 I released in mid-March, and I'm really proud of it. Big focus on refactoring. I was just listening to Greg Shackle's talk about unit testing, and he has converted me. I'm one of the converts, and he's given me a lot of suggestions as to how to structure things. So thankful for that. So there's now unit tests, and those are growing. And don't be surprised if you put in an issue request that maybe I say, hey, can you maybe see how you could create a unit test to reproduce that for me? So things are decoupled a lot more, and in doing so, they were simplified greatly. So it's just all around, I think it's a way better library now. The APNS support is a lot better, and that's really always been the problem area if there was to be one, just because of the weird protocol that Apple uses. And it scales a lot better now, too, because of being able to use unit tests to make that a lot better. So now's the time where I do a scary live demo, because network connections are always fun. So like I said, I'm going to try and take you through the steps of creating an iOS application right from the provisioning portal all the way to sending a notification with PushSharp. And to start out with doing that, the first thing that we have to do is go into our developer portal. And so I just went to the iOS Dev Center. I'm going to do this again to make sure I'm logged in. And it's now called Certificates, Identifiers, and Profiles. It used to be Provisioning Portal, and I'm just glad that they changed it like a couple weeks and not a couple days before today. So go into Certificates, Identifiers, and Profiles, and we're greeted with this screen. So the first thing we need to do when we're setting up an app is create an identifier for it. So we'll go in and do that. And I've got a few there already, but I'm going to create a new one for this demo. We give the app identifier a name, so I'm just going to call it push talk. We can enable push notifications at this stage, but we'll have to come back and do a little bit more configuration for that. Now, the important next part is to use an explicit app ID. You can't use wildcard IDs for sending notifications, just like you can't do it for in-app purchases and iCloud and all these other things. So you're probably doing that anyway. So I'm going to just call it com.evolve.pushtalk. And I can create that identifier. And Apple likes to confirm things about 10 times before you actually do them, so I have to submit. And now it's telling me, okay, registration complete. So I'm not quite done with the app identifier yet. I still need to set up a certificate to use to connect to the APNS servers for this particular app ID. So that's how Apple knows which app you're sending notifications to. It's based on the certificate you're connecting with. And that's authenticating you against the Apple push notification server. So I go into the settings. You can see push is enabled, but there's no certificates created yet for either development or production. Now, this is the first step where things start to get a little bit confusing with Apple. And just keep in mind that if you're using the development certificate, you are only connecting to the sandbox server. So that's what we're going to do for the demo. I'll create the certificate. Now, I need to create a certificate signing request. And it's just telling me the steps of how to do that, but I'll show you. So we go into Keychain. And actually, I'll zoom in at the top. And under the Keychain menu, to do a certificate request, we go to the Certificate Assistant, and then they request a certificate from a certificate authority. And we need to fill out a couple fields, like the email address. We don't need to fill out the CA's email address, because we're actually saving it to a disk. And continue. And it's just going to go to my desktop by default. That's fine. And we're done that. So we can come back to the portal now and add our certificate request that we just created, so it's on my desktop. And I'm going to go generate my certificate. Now, as soon as this is generated, we need to pull it into our system, and we'll get it into Keychain, and actually we're going to export it again. And we'll export it to a file that contains both the public and private key, because the private key is what you use to authenticate against Apple. And that's what we need for PushSharp to use it. And that's also what you'd need for Azure or for Parse or any of those other services that are going to need that certificate. So you can see here now it's been created. One thing to watch out for is the expiry date. This has bitten me in production, where all of a sudden your certificate expires and push notifications stop working. So just be aware. They don't send you, they don't seem to like to send you an alert that says, hey, you should really renew your certificate. Maybe they will with this new portal. So I downloaded my certificate. I'm just going to open it up now in Xcode, and you'll see up here, this is the new one that just got created. So if I expand that item, you can see that I've got a private key here underneath my public key. Just close that up. And then we need to export it to a file. So if you right-click, or whatever that is in Apple land exactly, you go export your certificate. And I'm going to cheat a little bit, because I've got some structure set up already for the next part of the demo. I want to put the certificate right in the path where the application is going to run from. So I'm just going to call this push cert. And you can see it's a P12 file type. So I save my certificate. And it's going to ask me for a password at this point. And this password is just to protect your private key that you're exporting to a file. So I'm just going to use the password of PushSharp. Oh, I didn't type that right. Demo fingers. So we just enter our password for that, give it my keychain password, and now we've got that certificate exported to the file. So we're done with the keychain, and we're done with this app identifier. And now the next step, and this is where things get a little bit more complicated, and honestly, probably like 30% of the issues that I've gotten over the couple years that I've worked with this stuff have been related to not matching up all of the right things. So what you need to keep in mind for provisioning profiles is there's three types. There's two types, and then one has two subtypes. We have development. Let me just zoom in on that for you. And we have distribution, which includes the App Store and ad hoc. So if you're using the development provisioning profile to sign your app and to register for push notifications, the device token that gets generated can only be used with the sandbox server using your development SSL certificate. So the easiest way to remember that is like development SSL certificate, sandbox, development provisioning profile. A lot of people mix up trying to use the sandbox to send ad hoc notifications, and Apple is not very clear when you try and do that what the problem is when you're sending them, so keep that in mind. So we're going to create a development provisioning profile. And we have to pick the app ID that it's associated with, so push talk. And then we select our developer certificate. And finally, some devices, because we wouldn't want to allow free distribution. And we give it a profile name. So I'm just going to call it push talk. And I like to put on the end of the names the type of provisioning profile it is, just to keep it straight when you're looking in Xamarin Studio or Xcode. So I'll create that provisioning profile, and then I'll download it. We'll open it into Xcode, and at that point, Xamarin Studio can now see it, and now we can start to create our client app. So that's been created. I'm downloading it, and I'll just grab it from my downloads, open it up, and now you can see it's been imported into the Xcode organizer. So we're good to go to start creating our application. Now, I've got some shell apps created just to save some time and boringness. And one of them is an iOS app. It's just a simple single view app. Don't need to care about the UI for this. All we're doing is registering for notifications and receiving them. So we go into our app delegate, and the first thing we need to do is tell Apple that we want to register for notifications. And we do that by calling UI application, if I can type it, dot shared application. And I'm just going to zoom in here a bit more too. Dot register for remote notification types. And this method takes a parameter of what notification types we want to use. So there's the alert type, and we can register for multiple ones. There's the badge type, and I'm also going to register for the sound type. Now there's this newsstand content availability if you are doing newsstand apps. I don't think you'll be using that one that often. So this is the call that actually causes the user to be prompted to accept notifications. And you've probably seen it in your apps when you open them. Would you like to allow this app to send you a remote notification? So you can actually call this anywhere in your app. It's not, you don't have to do it right in the finish launching. So if you want to put it somewhere else, that's fine. But for the demo, I'm just going to leave it there. And now the next thing that we need to do, because the user can accept or deny our request, we need to listen for when they've accepted our request. So we override, and this does have to happen obviously in the app delegate, we override the registered for remote notifications method. And you can see this method sends us the application that they registered for notifications for, kind of obvious, and the device token in an NS data type. And the easiest way I've found to get that device token into a format that actually works with PushSharp and most of the other services is just to call actually they'll put it into a variable. So if our reg ID equals device token dot description, which kind of prints it in a user-friendly way. But it also attaches some unwanted characters for our purposes. So I'm going to get rid of the angle brackets that it puts in. And I'll scroll over. And also the spaces that it puts in. And there's probably a more elegant way to do that, but that works for now. Now this is the point where you'd want to do something with this ID. You probably want to send it to a cloud service. Like I said, if you've got your own REST API or something out there, that's what you would do. But I'm just going to write it to the console and registered. And I'm going to go reg ID. Oh. And we'll take that from the console, we'll take that output, and we'll save it for later to send a notification to this device. So the other thing that we need to do when we're setting up our application is go into our project properties, and we need to start filling out some things like the application identifier. I'm going to put a name on it just to make it pretty. And this is the identifier that we registered with in the portal. So for this case, it's com.evolve.pushtalk. And I'm going to put in a version number just for fun. And when you have that identifier, it should pick the right provisioning profile automatically, but I just want to be a little bit sure that it's picking the right one or that we're doing it correctly. So I'm going to pick the push.dev, and this shows you what that provisioning profile shows up like on your system anyway. Yep, that's the one I just created and imported into Xcode just by opening the file. Yeah, it should find the right provisioning profile, but you can go in and explicitly set which provisioning profile it uses, and then you'll see in your build if you might have problems a little with that afterwards too, but you'll notice it in your build that it'll fail and it'll say something about provisioning profile. Well, for the purposes of sending the push notifications, you have to have the specific notification or provisioning profile. So we know now when we've registered for notifications. The other thing that I haven't put in yet is when the user may be declined or something else happened, something else failed. So I'm just going to grab a code snippet that I've got. We override a few more methods. The failed to register for remote notifications gives us an error. The received remote notification. Now this is kind of interesting because on Apple, if your app is in the foreground, if your app is running, it won't actually pop up a banner for you. It won't actually play the sound. It's assuming that you might want to do something different with it. So they just give you this method call, and it's only called when your app is actually doing something. And you can deconstruct the payload that gets sent in this notification at that point. So I just did a little example of grabbing the alert that we're going to send in the notification. So at that point, I could either do my own local notification if I wanted to, or just simply do something like this and show a UI alert view. But you could use that to maybe get some custom identifier that you've included and like open directly to the new message that came in or something like that. It's quite useful to have that option. So I believe that I should be good to go, and I'm going to compile and run this. And you'll notice I'm running this on Jonathan's iPhone because, unfortunately, you can't run push notifications on the simulator. So don't try. So the app's running, and it's launching on, you don't need to see the camera right now because there's nothing interesting, it's just a blank view. But what we are interested in is this registered message. This string here is the identifier that we need to send push notifications with. This is that unique address, that unique string that we need that we're going to use in PushSharp in just a second. So I've copied it to the clipboard, and we're going to go into our server. I'm going to stop the program from running. We're going to go into our server. It's just a simple console app. I'm going to set it up to run to be the start project. If you look in the references, I've already added the PushSharp references, which include the newtonsoft.json. For the demo, we're only doing Apple. We really only need the pushsharp.core and the pushsharp.apple as well as the Newtonsoft. But just to show you which references are available. And these are all on NuGet. And actually, I've even done some testing. The NuGet add-in that someone has created out there for Xamarin Studio, it works fine to bring them in via that as well. So I've got my references set up. And I've even got a couple of usings set up here. And one of the important ones, since version 2.0 of PushSharp, there are some extension methods to ease the pain of registering or setting things up for Apple or setting things up for Google or all the different platforms. Because those things are now decoupled, the easiest way was to add some extension methods, which you only get by calling it or pulling in the using PushSharp. So I'd recommend you do that first thing in your project. So we're going to set up a push broker instance, and the push broker is what basically figures out which service to send which notification types to. So you have this one single point where you can queue notifications, and it'll just go to the right services as long as you've set those services up. So I'm going to say var push broker equals new push broker. Very simple. And the next thing that I want to do is I want to set up Apple to run. And now by default, if I didn't have that PushSharp using namespace in, we would actually have to call something called the register service method. And what this does is it takes a type of push notification and it associates a given instance of a push service with it. So that's how the push broker works, but since we have the extension methods available from the Apple side of things, the Apple code, we can just call register Apple service, and that will simplify things for us. And register Apple service takes a Apple push channel settings, and optionally a push service settings instance. But we don't have to do that. There's some default values that will go in if we don't. But if you want to change some more complex things like fixing the number of connection or channels is what the term I use, which a channel ends up being either a thread in the case of Google and some of those HTTP-based services, or in Apple's case, it's actually it represents a connection to APNS. So by default, PushSharp will auto-scale for you or try to auto-scale for you. And in some scenarios, that might not be ideal for you. So you can actually go in and pass it a push service settings object instance to specify how many channels you want it to use, to turn off the auto-scaling, and there's a few other options in there once you get into more advanced things. So I need an instance of push Apple or Apple push channel settings. So I'm going to do that first. I'm just going to comment this out for a second. So I'm going to go, actually, before I do that, I already know I need that certificate file that we made earlier. So I'm going to get that into a byte array. And I'm just going to go var cert equals file.read all bytes and path.combine. I'm going to go with the app domain, the current domain, and I'll get the base directory. And I think we named it push cert, and it's a .p12 file. So that code there is just going to get our certificate into a byte array, which we can then use in our Apple push channel settings. So I'll do var Apple settings equals new Apple push channel settings. And this method takes, there's a bunch of different overrides or overloads. You can pass in the file name, you can pass in the byte array, you can pass in the actual certificate instance. The easiest one and the one that seems to work quite well is by passing in the byte array. So that's what we're going to do. And then we also have to pass in the password. And if you remember when we exported from Keychain, we had to give a password for that file. Well, this is that password. So we called it PushSharp. And optionally, you can specify to disable a certificate check. So by default, I'm trying to help you not make those same mistakes that I've made all too many times of confusing development with production. So this will actually check the certificate and try and figure out if you're doing the right thing or not. So in some cases, I've had people have to disable that for various reasons. But I'm not going to do that today. So we've got our Apple settings, and now we're ready to actually register our Apple service. So I'll pass in our Apple settings. And now that's all ready to go. It's ready for us to start queuing notifications to it. So to queue notifications to it, we need to create one. So var n equals new Apple notification. And this is where that sort of fluent-ish API comes in. So for Apple, we need to pass it a device token, because that's what they call their unique ID. So I'll say for device token, and I hope I still have that on my clipboard, and I do. And that's telling it who to send that notification to. And then I'll say with alert, which on Apple's platform is what text pops up. Hello, Evolve. And then I'll say with badge, and that's going to update that home screen badge number for us. So I'm going to say 3. So that creates our notification for us, and now all we have to do is call pushBroker.queueNotification and n. Now, by default, and I get this question a lot, I recommend that you keep the instance of PushBroker alive as long as is reasonably possible in your application. The reason being, Apple says in their documentation not to keep opening and closing connections to them. They don't like that. I've never heard of anyone actually getting banned from them for doing that. And I've actually had, in some of my testing, done some pretty funny things where I was opening and closing like thousands of connections to them, and I've never heard anything. But best practice is to keep those connections open. So if you're running a Windows service or something like that, keep an instance of it. In ASP.NET, often what people are doing is creating an instance in your global ASAX. So keep that running. And for this demo, we're not keeping it running. So what we need to do, and you should do this anyway in your other applications in your shutdown procedure, or like in your global ASAX when the application is stopping, we need to actually call stop all services, and that gives us the option to block, to wait for all of those queued notifications to finish. Because what happens when we queue the notification is that method returns right away. That notification goes into the queue, and it'll get processed as quickly as possible. So that should cause a notification to be sent to our device. Some of the other things that we can do with PushBroker is there's a bunch of different events. So we can listen for a channel to be created or destroyed, or the channel exception. And because we're dealing with different platforms, there's different kinds of exceptions on each platform. This is an area I'm looking at improving a little bit, but you can figure out what type of exception it is, cast to that exception, and get a little bit more detail about what happened in some cases. There's also events for the notification failing, being sent, or the subscription expired, which is something that happens on all the platforms, but the only odd one out is Apple. It'll still happen, but it doesn't happen shortly after your message is sent, because with Apple, we have to actually, oddly enough, we have to poll their push notification service for feedback. So I'm not going to register any events right now, but there's some things that you can add into your own code to keep track of things. So I think we're ready to go. I'm going to switch over now to the camera. And I don't know if we're going to be able to see it that well, but I'm hoping that a banner notification pops up shortly. So I click run, sending, and there we go. You can't really see the words of it, but it does say push talk, hello evolve, like we queued up. So that's really all there is to sending notifications. It's not that hard. The hardest part I find is setting up the individual platforms, like the client side of things. And unfortunately, that's just going to be a pain point because that's how Apple's done things, and Google is different or difficult in its own way. But using PushSharp, I'm hoping that it's fairly easy for you. It's something that maybe you can try out, and that's it. Does anyone have any questions? I think there's, if you want to pass around a mic.
I hope this isn't too much of a noob question, but is it possible to target a specific device ID, like send it only to a single user?
Yeah, no, by default, that's every notification you construct will go to a specific user. Now, Google is a bit different. You can send multiple device IDs to send a notification to, but Apple doesn't really have a concept of that. You have to send one notification for each device ID that you want to target.
Excellent, thank you.
Is the token on the client, is that the ID on the hardware, and is it safe to actually use that, or is it frowned upon?
It's not the hardware ID. It's actually, in Apple's case, the token is unique to your application and to that device. So a user could actually have multiple devices. So often when you're designing your server side of things, you'll want to think, like if you're thinking about it from a database, you'll want to store maybe multiple device tokens for a single user account because they could have multiple IDs, and that token is only unique to that specific device for that specific app.
And what about the version of the application? Is it something that...
It's definitely possible that that can change. So what you need to do in the case of Apple specifically, you need to call that register for notifications all the time, basically, or often. And then you see if that's changed. So often what I do is I store the current one in some kind of file or user preferences, and then compare that when I receive that callback and see if it's changed. And if it's changed, then I'll call out to the web service and update it. But it is possible to change, and on all the other platforms too, it is always possible that changes on you.
This isn't necessarily a question, but just a comment from my experience with it, and handling the certificate password. The Apple's pretty specific about what you not disclosing or compromising it. So one good way to handle it is to use the built-in features of Azure on the web, like for a web role. Basically, you can deploy the certificate just like an SSL certificate that your client would connect through their browser or their web service. and then it basically, you don't have to handle the certificate at all, other than just when you're doing the initial setup. So there's a page on the GitHub wiki, I think, that describes it. So definitely worth looking at, and it's saved some issues that I could see a client having with the security of that.
Thanks.
Can you send alerts that don't toast, that don't have any GUI impact? And then what is the payload size of this amount of data you can send with a notification?
So the payload size on the different platforms is different. Each one has their own limit. The idea behind the notifications, I think, is to send small bits of information, like you kind of call it a tickler, so that your app knows that it should go out and check for more information. In the case of Apple, there is no way to send a notification that doesn't cause something to happen, like a banner or alert or a sound or something like that. On Windows Phone, there's raw notifications. On Google, you don't actually get the UI stuff for free when you send notifications. You have to say, hey, put a notification in the drawer. So by default, it comes into your app as an intent. And basically, you have to decide what to do with it at that point. So they're all basically raw notifications for Google.
Yeah, but I remember you mentioning that if, at least in iOS, if the application is in the foreground, you won't get the badge and is that correct?
Right. So at that point, you could choose to do a local notification to sort of simulate the same effect.
I mean, we're asking this because we're in a dilemma right now about using Signal out or not for certain messages that we need to receive.
Right.
Like change in the position of the user or things like that. That we don't want the user to be bothered with that in the bash or in the notification area. But on the other hand, we don't want to consume all the battery by keeping a persistent connection in the background all the time.
Well, and with Apple, unless you're a special type of app, you're not going to have that opportunity to keep the connection open anyway. So yeah, on Apple, there's no banner displayed for you if the app is running. So at that point, you have the opportunity to do whatever you want with it in the app.
Hello. Do you have a video of this presentation?
I think Xamarin, folks.
Okay.
So videos will be released after at some point.
Okay, thank you.
I will be also posting a video. I didn't have enough time today to do it, but I wanted to do the same thing with Android as well. So I'm going to post a video of that look for it on the GitHub repo at some point.
Okay, will be great. Thank you.
This is just a follow-up to the previous question. Is it possible to send just a badge push on Apple? Just to increment a badge without a toast or anything it interrupts?
Yeah, you could send just a badge notification.
Following up on that, is there any way to, when you receive that badge notification, if you wanted to do something more silent, could you just decrement back the badge after you receive it?
Well, you could, but the problem is Apple doesn't pass that notification along into somewhere that you can do something in your app until the app is launched. Or they don't pass anything in, or they pass some arguments in when the app is launching to tell you that a notification caused the launch. If you go look at the code in the app delegate, this will be real quick, but in your finished launching, this NS Dictionary options, that'll have similar data to your received remote notification user info dictionary if a notification caused your app to be opened.
In your demo, you used just a copy-paste to get the device token over to your server app. Is there any recommended by Apple way to get that, or you're just on your own to pass it to your server?
Yeah, you're kind of just on your own. One of the things I've toyed around with the idea of is creating kind of a more appliance-based approach to having some kind of web service up there to store those in. So if you have any ideas or anyone has any ideas of a nice way to implement that or has implemented that, I'm all ears. All right, well, sounds like it might be food time then. Thanks, guys, for coming out.